Okay, so we are group 7 and we're solving problem 1.3 parts C and D. So right here I just have the beginning of the free body diagram. I just added in all the known pieces so far. So we have 2 masses, 2 springs, and a damper. I also added in the displacements that were given in the problem statement and also the applied force. So I'm just going to start by adding in the other displacements that we know. So since this piece right here is connected to the mass, we also know its displacement is x2. This piece right here is connected to this mass, so we know its displacement is x1. This piece right here is connected to this mass, so we know its displacement is x1 as well. Same down here. And then these right here are just connected to the wall, so their displacement will be 0. We'll mark it on both sides. And then, yeah, so those are all the displacements. So now we'll add in forces. So we have an applied force here. So the reaction force to that is going to be F1. It's not the same as F because this object has mass. And then it has an equal and opposite reaction. Over here we have, oh, it's actually the same. Sorry about that. These are F1 as well because the spring is massless, so it's going to be the same force. Then up here we're going to have F2. And down here, we'll have F3. And then these same reaction forces this way. Okay, so now we can start doing the equations. So I'm just going to start with the spring equations. So I'll say K. So I'm going to start with this spring, spring 1. So we have force F, so F3 equals K1 times displacement. So displacement is x1 minus 0. So I'm just going to write x1. And then the other spring is K2 here. So the force applied to that is F1. So we have F1 equals K2. The displacement here, we have 2 different values. So since x2 is in the same direction as the force, that one will be positive. x2 minus x1. Moving on to the damper, we have here the damper. The force applied to it is F2 equals C for the damper, and then the displacement is x1. But it's actually a velocity because it's a damper, so it's going to be x1 dot. And then we're going to move on to the masses. So we'll start with mass 2 right here. So the forces, the sum of forces on this mass is going to be F minus F1. We do it in that order because F is in the same direction as the displacement coordinate. And this is equal to m2 times x2 double dot. And then the other mass equation is going to be the sum of the forces on this mass. So we have F1 minus F2 minus F3 equals m1 x1 double dot. We did the forces in this order because F1 is the only force in the same direction as the displacement coordinate here. Now that we have all of our equations, we just need to substitute in for the force values to find our equations of motion. So starting with this equation here, we're going to substitute in for F1. And then I'll simplify this to be in standard form. So there we have one equation of motion. And then this other equation we'll plug in F1, F2, and F3, and then simplify it to get our second equation of motion. So for F1, and then we'll rearrange that to be in standard form. And then there we have our two equations of motion for problem C. Okay, moving on to problem D. So here I have what is given in the problem statement, 2 masses, 2 springs, and 2 dampers, and then the coordinates of displacement. So we'll just draw in the other coordinates that we know. Since this piece is connected to the mass, we know this will move by x2. Since this piece is connected to this mass, we know this will be x1. Since this piece is connected to this mass, another x1. This is connected to the wall, so it'll be 0. Same with this down here. This piece is connected to this mass, x1, and again, x1, and here we have x2. So now for the forces, so we are going to have force 1 here, equal and opposite, and then that will also be right here. And then down here we will have F2. Equal and opposite, because the spring and the damper are both massless. And then on the other side, we will have F3 here. And then F4 down here. Okay, and then our free body diagram is ready to go. So we'll start with the equations of motion. So we're going to start with the springs again. So I'm going to start with spring 2, and the force on this spring right here is F2. So we have F2 equals K2 times X2 minus X1. We do X2 minus X1 because X2 is in the direction of the force. The second spring right here, we have F4 on it, so we have F4 equals K1 times X1 minus 0. Moving on to the dampers. So for this damper right here, the force applied is F1 equals C2 times X2 dot minus X1 dot. And we do that order because x2 is in the same direction as the force, while these are in opposite directions. And then for the other damper, we have force 3. So F3 equals C1 times x1 dot, because we're just subtracting 0 from that. For the masses, we're going to sum the forces around this one first. So we have F minus F1 minus F2 equals M2 x2 double dot. We did this order because F2 follows in the same direction as x2 and the other two do not. For the other mass, we're going to add up these forces here. So we have F1 plus F2 minus F3 minus F4 equals M1 x1 double dot. Forces are in this order because these two forces go in the same direction as the displacement, while these do not. And then finally, we will just start plugging in and substituting for the forces here to get our equations of motion. So starting with this one right here, we have F minus F1, which is equal to C2 There we go with that. And then we can just simplify that into standard form. And then there's one equation of motion. Now we'll use this to get our second equation of motion. So we're going to plug in for F1 first. And we'll just simplify that into standard form. And here we have our second equation of motion, and we're all done.